LeetCode. Alright everyone, it's June the 6th. Alright, replace words. English, we have a concept called root, which can be followed by some other word to form another longer word. Let's call this word derivative. For example, when the root help is followed by for, we can have helpful. Given a dictionary of many roots and a sentence consisting of words separated by spaces, replace all the derivatives in the sentence with a root forming it. If a derivative can be replaced by more than one root, replace it with a root that has the shortest length. Return the sentence after replacing. So, the cat was rat by the bat. Okay, so it's a try, right? For each one, we just try to search if we can find. Okay. Try. I think we did this before. We have a try, and I think we use a try node. Right, I think we do class try node. Instead of try node, what do? We say a boolean is and, right? And we have a try node, a list of try node children, new 26. I'm not sure if I can do it here, so probably shouldn't do it here. Let's just say try node, yeah, try. Actually, no. Right, try node. This dot is end is false, and this dot children is going to be new. Try and call. Try node 26. I think that's a try. Okay. Now we're gonna create a try first. Okay, so what do? We say try node root. Okay. For string dict of dictionary. Okay. Then we say try node equal to root for character C of dict dot to char array. Right. What do? We say is this no? It's a good question. I don't know. Default value of array of class. Fields in your array should I with no. Okay, maybe I can be more explicit. Arrays dot fill this dot children So now we can say if node.children c minus a, right, is equal to null, then node.children c minus a shall equal to a new try node. Okay, and then say node equal to node children c minus a. All right, so we can probably index equal to c minus a. Okay. To the last one, node dot is and equal to true. All right, so now this we go through all the try, and then we're gonna go through the sentence, and we need to create a new one, right? Sentence. How do we break? I do not know. How do we Java string split? They have a split function. String.split, okay. I forgot. Java list of string join. String.join list. Okay, that's good to know. Then we just say list string rest list new array list. Can we just say for string s of sentence.split? Okay, can I do something like that? I think it has to be a string. Split by space. Ugh. All right, I'll use rejects. Just provide a rejects, okay? Okay, so like that. And for each one, we need to check. Actually, it shouldn't be boolean, right? Because it shall be string. Dict. Can I say no? Yeah, I can say no. Then string dict. Nah, let's call it str. Okay, this is fine. This is fine. No, this is fine. Okay, this is str shall equal to dict. Okay, so we say try node equal to root. And we go through everyone for char c of s dot to char array, right? Index is equal to c minus a. Then we say if node dot children index is not equal to no, then node equal to node dot children index. right? And then else break. Then how do you know you have traversed through the entire thing? We don't, right? We don't. Which means we shall use I equal to 0 while I smaller than s dot size length int index shall equal to s dot char at I minus a. Right, everything else will follow. Right. Then I plus plus. Right, I plus plus, next one, next one, next one, next one. Once they get out, we say if I is equal to I plus plus, I is equal to s dot length, which means we have go through the entire s, right? And what? When they get out, node dot str is not equal to null, right? That's when we say res list dot add node str. Otherwise, res list dot add the current s. Right. Okay, blah blah blah. Once we're done, we'll return res list dot join. Uh-oh. Here's no join. Wait, hold a second. There's no join? String.join, my bad. Okay, so we have to do string.join rest list. No, I think it's the thing first and then rest list. Okay. Let's give us a shot. 36. That was bad. Oh, no. Yeah, okay. No, I was wrong. Sorry. Hold on. This is not right. We need to find the first time. Okay. All right. Hold on. Index. Right, index, and we check, because we just need to find a root. Right, we need to find a root. Okay, that's not right. We should just go through the one by one, and the first one that can hit, then we shall get it. Okay. Yeah, this is not right. That's all right. I kind of misunderstood the problem. So, how would you do it? I would say for int I equal to 0, I smaller than dot length, and node dot str is equal to null, right? I plus plus. Then we don't need this. We need all this, I think. So we get the index, we do that, right? And if it does not exist, we always, we just jump out. If it does not exist, that's actually fine, because what we can do is and node is not equal to null, right? if node is not equal to null and node.str is null, right? And if we do that, we can just directly, you know, do this. So we don't need this, right? And then when it come out, all we need to check is node, right? If we say node is not equal to null and node.str is not equal to null, then we do this. Otherwise, we do this, right? Although if it come out node is null, which means something is bad, right? Then we don't do this. Or we come out node.str is null, that something is bad. Okay, so we make these changes. Yeah, this is not right. Okay, let's try this one. All right, I think I can make this because we only use this index thing once. So what we can do is do this. Okay, so I'm gonna put some notes here. LeetCode 648. Create a try for dictionary, then go through each word in sentence and search its root in the try. If a root exists, use it. Otherwise, use the original word. Okay, that's we call it ONK. So N will be, I mean, it depends, right? We can say OM plus N times K, right? Where M is length dictionary, N is length sentence, right? And K is the, let's say, average length of each word in the dictionary. Because that's basically it. We go through everything and then we go through the try. And the number of times the try needs to go, actually not true. This is the word. This is the word in the sentence. Right? This is a word in the sentence. That's actually not true. I can say the average length of the words of the word in both the dictionary. Yeah, might as well just do it the other way. Like, let's do it MP plus NQ. How about this? M, N, and we say P is the average length of word in the dictionary, and Q is the average length of the word in the sentence. Okay, let's try it again. Alright, I'll run it. Okay. That was not bad, but 35 milliseconds. I wonder whether try is the best one, because the dictionary is small, right? And the length is small. Sentence is long. Number of words. The length of each word is 1,000. I don't know. I feel like it should be a try. Let's see what we did last time. Did we use a try? Yeah, we used a try. Yeah, it's exactly the same. 126. Do we have more test cases? Oh, we have 127. Hash set. prefix try. Yes. Okay. Yep. Pretty standard, right? This one's pretty standard. Okay, we have about 10 minutes. I want to spend about 10 minutes. Let's try to implement this. And we have to go back, I think, a few more days. Yeah, we'll go back here. Oof. That'll be interesting. The implementation. Okay, so first of all, we do not use this at all. 2836. Okay. 2836. 2836. Okay. So, oh yeah, this is not gonna work. All right, so we're gonna use all the hints. So first things first, what we need is the binary representation. Okay, that's actually, we can say bink is equal to binary k. I believe it's 2 to the n. Okay, so we have a binary k, and we need m. M is the number of the receiver, right? The receiver length. The receiver length. So M shall equal to len receiver, right? N is equal to, we probably can do this, mn bink. Okay, so now I have mn. What next? We need LR and S. We're going to say LR equal to 0 times n for this in range m, and we call this is last receiver, right? And S is equal to same thing, right? S is same thing for this in range m. This is sum. Okay, sum. Alright, so now we have the two of these. What's next? So next is we're going to fill in 0, 0, 0, 1 and then 0, 2. Alright, that's for the last receiver. And the last receiver, basically, we need to say starting from 0. Actually, no. I think it's a 0. Yeah, 0, 0 with a 0 position. Just one step, right? One step. So it's starting from 0, and we do one step. What we end up at, right? The last. So basically, this will be 2, 0, 1. We just copy this, right? Copy this, and we say for for j in range m. No. We do 0. J is 0 for I. This is going to be I. For I in range m, LR I 0, right? Because the 0 step shall equal to receiver I. Okay, so that's filling the first one. Then we are going to, hold on, let's say populate the last receiver matrix. Okay. Now we're gonna fill in everything. How do we fill? Well, we're gonna say 0, 1, right? 0, 1, 1, 1, and 2, 1. So for j in range, so 1 to n, then for I in range m, so LRIJ, right, shall equal to So we started from I, we ending at j, right? Which is equivalent to we starting from I, right? So we starting from I, but with j minus 1, so we half the way. So this is the end position of here, and we're starting from here, right? We're starting from here, and we'll do j minus 1 number 2 to the j minus 1 number of steps, right? So that's that. Okay, yeah, that's basically how we handle this. If you see, I don't think I write it, but we have the formula here. Last receiver, this is equal to last receiver this, yeah. Now we're gonna handle this sum. Right, populate the sum matrix. Again, Si0. I think it's the same thing, right? Yeah, it's the same thing. So this is going to be receiver I. Then for j in range 1 to n, for I in range m, so we're going to compute Sij. Okay, so Sij will be the sum of from I to j minus 1, right? So starting from I, go to 2 to the j minus 1 times, and we have the receiver. From there, actually no, it should be from Si to j minus 1 plus, right, to I to j minus 1, and then we'll find the last receiver from I to there, and from here we go the remainder. So that's this. Sum this equals to sum this I minus 1 plus sum last receiver this and this, right? That's that. Okay, so now we populate both matrix, right? And pay attention, this one does not include the first one, right? Does not include the first one. So when we do the actual computation, we have to include the first one. Now what we need to do is go through the bank, right? We go through the bank. Ideally we need to go, I mean it's 0, 1 from right to left, right? We go from right to left. Yeah, that's fine, from right to left. So we get the first one, so we say we're starting from whatever, we go to here, right? And then we go to the next one, which basically is the previous one, right? It's the position. Yeah, we need to know which positions has 1, basically, right? So we need the positions. Okay, so we can say positions equal to for I in range n minus 1 to, so from rightmost all the way to 0. That's not really true, but what we can do is okay, so we have this as a bink, and I think I want to use bink once, right? Yeah, so we can do bink reversed. Huh, I wonder, maybe this is reversed. I do not know. I actually have no idea. Oopsie doozy, sorry. I need to go to my, here. Alright, so we need to do PT Python. What I want to find is, let's say foo equal to, I don't know, 111,000, right? No. Foo equal to, let's say 42. Okay. So bin foo 2 to the end is this. So what if we do this? Did we get the reverse version? Nope, it does not. Damn it. Alright, so I need to get this, then do this. Yeah, okay. That's fine. So to the end, and then we do reverse. This doesn't matter. Being rev, right? What we need here will just be from the start to end. We say if bin bink reverse I is equal to 1. Alright, if it is, then we will add I. So that's the position. Okay. Which I just realized I don't really need this. I can just go through. Alright, I mean, why do we need this? I can just go through. It's just this if condition. We can just do if. So if this is equal to 1, then we will... Oh, then we don't know the previous. Ah, that's why we need the other one. Okay, yeah, we need the previous. That's fine, that's fine. So now we have positions. Then we are going to go position one by one, right? And each one we hit, we get a sum, right? Okay. So what we need is the rest is equal to 0. Okay. And we need to find the maximum, right? Okay, so for x for start in range, I don't know, receivers m, right? So we need to find, like, to compute the score, right, of starting from st and go k steps. And we say current is equal to st, because that's the start, right? And then what we're gonna do is go through the positions, right? We're gonna go through the positions. We say for p in position, actually no, because we need a previous one. For we use I already. You want to use I again? Okay, let's use p in range len position. Okay, so we say if p is equal to 0, then current plus equal to will basically go to the s, right? So it's the sum of the starting position and we have the end position. P. No, it's not p. Oh. Okay, I don't like it. I do not like it. I'm gonna use I. Okay. And this is gonna be position I. Right? So we're starting from here, we're ending with this. That is the first round. Okay. And then else, if I is not equal to 0, then we have a previous. Then we need to find the previous, right? And then we're starting from the previous. Hold on. Let me think. How is this one handled? We'll go. Yeah. Let me do one more time on this one. Let's say we have 7. Okay, 7 is 1 1 1, right? And we say we do 2. No, that's a 1 step. Yeah, that's a 0 position. 0 1 2. Hold on. It is this, right? You hit 0. You do 1, right? And then you do this number of steps. You do 2 more steps, starting from whatever you have. Then you do 2 more steps. Okay, yeah. So that's actually correct. A couple of things. So these are the positions. Okay. So we need to do the position. So yeah, this will be like a 0 something something, right? So else, so current plus equal to, still S something all the way to position I, right? All the way to position I, to that specific position. And then the previous one shall be the last receiver, right? It should be like this. The last receiver starting from where and then go where. Oh, dude. Oh, man. Starting from where and then go where. But technically, when we start from the start, right? And then go to position I minus 1, right? We go to position I minus 1. But the next one shall be, yeah, we start from there, we go to this position, right? And then we need to go that many more steps. Holy crap. Holy crap. Holy crap. So we need a minus. Oh. Okay, so I'm gonna do something really. Yeah, the current is right. Okay, and then if it's 0, it's gonna be from this to this. I agree. If it's not 0, then we need to find this pre. But this pre is, man, this is killing me. This is killing me because because 0 is this and 1, it's actually different, right? L if I is equal to 1. So current plus equal to, it's from ST, right? Because it's the last receiver from ST going to position 0, right? So if I is equal to 1, so go to position 0. That's the receiver position. And from here, right? And then we'll go position I. See what I'm saying? Right? And else, then we can say this is going to be Nope. This is not right. No. So I need to know, okay, let's do this. Previous receiver. Okay. So it's gonna be ST. So this is the previous receiver. Okay. All right, so let's say now we can say for P position in position. Okay, so position. Now current will plus equal to S, the sum from previous receiver all the way to the current position, right? And then previous receiver shall equal to last receiver of previous receiver going to the current position. And if we do that, is that right? Current, we have the starting position, and the starting position is like the previous receiver, right? So the first one coming in is going to be from the previous receiver all the way to the current P position, right? Current P position. So we add the sum, okay? And after that, we compute the new previous receiver for the next round, which is the last receiver from the previous one go to the current P, right? And then go to the next round, PR. This looks about right, right? This looks about right. And we'll blah, blah, blah. Then we compute a current. We can technically do this, right? And we can say PR is the previous receiver. So blah, blah, blah. Once we're done, and we shall say rest equal to maximum, rest and current. Okay. So blah, blah, blah. Then we return rest. All right. Moment of truth. Moment of truth. Let's make sure the first one is right. Dude, this is a very tough problem. Okay. First one's right. How about the second one? I think this is right. Very likely to be right. Okay, so now let's write this. Not able to solve this problem on my own. The following is an implementation. Is implementation, right? Is implementation of all, was that 5 hints? 6 hints. LR is the last receiver where LRIJ is equal to the index of the last receiver when we go from I, and when we start from I, and proceed for 2 to the jth steps. S is the sum where Sij equal to the sum of all the indices. Alright, sum of indices when we start from I and proceed. Alright, start from I and then proceed for 2 to the j steps. Right. Then we use the DP, right, relationship basically to populate the LR and S matrices. To find the solution, to find the answer, we break down K into its binary representation, right? Can break down into its binary representation, and for each and starting from the least significant bit. If it is a 1, we go from some starting point to that. Now, if we started from, if the jth bit, right, is 1, we go from some starting point to 2 to the j steps and proceed to the j steps, right? This the S matrix allows us to find the sum of all the indices along the way, and the LR matrix allows us to find the last receiver, right, of the current round, right? Then for the next jth bit, which is 1, we start from the previous last receiver and proceed for actually I should say J1, right, steps. Okay, that's actually a better one. So if the J0 bit, right, then we go for J0. If this is J1, then we go for J1 steps and proceed for J1 steps, so on and so forth. This we can compute the total score, right, of going from the going from some starting point and proceed for k steps. And we go through this process for each index, right, in receiver and return the max score. I don't know, what's the runtime of this? Well, we have definitely n. Well, actually m, because I choose that is. So we can say O m, right, times log k. Right, log k, because the length of bink is log k. And the last one is a position is also log k. Yeah, so we just need to, let's do this, right, where m is equal to line receiver. Okay, I think if it pass, hallelujah. If it doesn't pass, well, we have, let's just try one more time, make sure everything goes for this. All right, now let's submit. It worked. It freaking worked. But boy, this is a tough one. Very tough one. And it has a name. That's the thing. It has a name for this method. It's called binary lifting. I'm not sure what that means, you know, lifting weights, binary lifting. Boy, it's a tough one. Binary lifting, binary jumping, slow, fast, sliding window. Wow. Tons of different methods. Each node has and only has one father. Continuous jump on the only path immediately thinks of binary lifting. Binary lifting is suitable for problems like father's father is the second order. The hell is this? Father's father is the second order father. Yeah. Yep, that's the same. Probably, what? What the hell? Why you define a function like this? Yeah, for position, for profit, yes. Yeah. Bit length. Oh, they use recursion for this. Yeah, it's the same, but still, that's a tough one. That is a tough one. Oh, this please don't be a Wikipedia page. Code Force. Okay. Lord. Alright, that will be it. That will be it. This is some tough stuff. Okay, now I'll see you guys tomorrow. Adios.